Hello and good morning, everybody. I would like to start here with the evaluation event meeting. First of all, thanks for taking part of the evaluation for the Velasco evaluation event. Our purpose is with the evaluation event is to get valuable feedback about your experience with the Velasco platform and his usability against expectation. We will also appreciate your impression on practical issues and any other comment or criticisms that you may find interesting. And now, let me start introducing you the Velasco platform, the Velasco project. Sorry. Emphasizing on the vision of the Velasco project, let me read a phrase that perfectly defines what is the, um, the goal of the Velasco project. The vision of Velasco is to provide new visual analysis methods for large-scale simulation, serving the petabyte era and preparing the exabyte era for adopting big data tools or architecture for the engineering and scientific community, leveraging new ways of in situ processing for data analytics and hardware accelerated interactive visualization. Velasco project is a project from FP7 program of the European Union and was funded with 3.3 million of euro. It is composed by a team of experts with complementary background, mainly on big data handling, advanced visualization, and engineering simulation. Let me continue now presenting the consortium of the project. We will see how the horizontal bar in the picture represent the division of the partner by country, and the vertical bars are representing the background of each one of the partners. In concrete, Atos is involved on big data infrastructure and end user testing. Simne and Fraunhofer are involved in data analytics and visualization tasks. University of Edinburgh and SINTEF are focusing on data analytics processes, and finally INRI and Jotny are supporting big data infrastructure issues and data analytic processes. Speaking about the simulation data and Velassco project, we could say that we are supporting two types of simulation data. On the one hand, we have discrete element method or DIM, which are mainly represented by means of particles and contact. And on the other hand, we have finite element method or FIM, based on the concept of meshes, which are composed mainly by nodes and elements. Continue now with post-processing of the simulation data. We are supporting in Velasco visualization of particle contact meshes with results, projection of discrete result into a continuum field, isosurfaces, cut planes, streamlines, and finally statistical results. Concerning the motivation of for Velasco project, we could say that due to the huge amount of data provided by solvers, in HPC cannot be stored in a single machine, and it's mandatory to provide distribute post-processing and distribute visualization. In addition to that, we need a redundancy for the data in order to avoid problem if a calculation node fails in HPC, for example. Related to the objective of the Velasco project, the main objective here in the project is to build the Velasco platform, which is a system that performs distribute post-processing operation and visualization of very large simulation. And to address this objective, Velasco brings together simulation and big data. Let me present now an overview of the Velasco architecture. Here in the picture, we in brown or red, we could see all the software pieces related to the open source version of the platform, and in green we have the commercial one or closed solution, mainly based on a proprietary product from Germany called EDM. We have different modules in the architecture related with access into the platform. And here we have the access library, used mainly by the different by our using our visualization client. Sorry. Related to the injection, we have the data injection module, which is supporting batch and real-time injections. Related to querying, supported by means of our query manager module, which is in charge of binding the petition to a set of modules in the architecture, as for example access, analytical, and storage module. And finally, related to the storing, we have in our storage module. We have a storage module, sorry, providing support for a non-SQL database, which is a trace, and providing support for an object-oriented database, which is EDM. Let me report now on the status of the Velasco platform. Currently, we have a first release of the platform, including on the one hand a set of simple queries supporting or providing visualization of particle and meshes with results, providing get result values for a specific particle or not, and finally providing temporal evolution of result. And we have on the other hand a set of let me say complex queries supporting projection of discrete result into continuum field, get simplified mesh and his companion get simplified mesh with results, and do streamlines with results. And during the next 2 months we will be supporting new complex queries, as for example get isosurface and get volume LR plane from bounding box. Continuing with the reporting on the status of the Velasco platform, I would like to mention here that the last version of the platform is currently deployed in our HPC cluster, hosted by University of Edinburgh, and we have here in the cluster 38 nodes, a local storage of 97 terabytes, and finally the network storage of the cluster is a little less than 400 terabytes. Finally, on top of the platform, we are developing two visualization clients that are Git and IFX, and that visualization client are the client that you will use for the execution of the use cases, defining for this evaluation event. And here conclude the presentation related to the overview of the Velassco project, and now I would like to continue with the presentation related to how to connect to the ED cluster. Thanks.